According to the current view of cosmology, our universe would be in continuous expansion. That is, the galaxies would be moving away from each other with ever-increasing speeds. These so-called inflationary theories present more problems than solutions. The problems begin when one takes into account that there is no absolute movement in space-time. The movement away from galaxies is only relative. This paradox, which predicts that stars move but do not leave the place they occupy in space, is compatible with the existence of a universe that would be static in its origins. To solve the enigma, science postulates that space would be stretching, dragging the galaxies with it. This thought leads us to another problem. If space were to stretch, its behavior would be similar to that of an elastic spring attached to a fixed end. When a spring stretches, an increase in elastic potential energy occurs. The energy of movement, the kinetic energy, decreases in a complementary way. So, expanding space could not directly promote the acceleration of galaxies. Knowing this, physicists proposed the existence of an energy that was overcoming the force of gravity. It was, appropriately, called dark energy because, to this day, its existence has not been confirmed. When we analyze the solution found by science to justify the expansionary movement being supported by the stretching of the space spring, we are led directly to the behavior of cosmic radiation. That is, by using the light emitted by distant galaxies, astronomers found evidence of the expansion in the redshift of the radiation. This deviation, naturally, was extended to the space itself. It is the light that behaves in a similar way to the mass spring assembly. Attributing the same behavior to space is a very risky attitude and cannot be confirmed or denied. Light does not lie, but it could have led us to mistaken interpretations, although justifiable. It turns out that we have no other tool to analyze the geometry of space other than light. It is light that tells us that space is curved and that stellar masses could divert the trajectory of radiation. The gravitational influence itself, exerted by large masses, is evaluated by this deflection suffered by light. All these problems could be overcome if we examine the behavior of the mass spring assembly more closely. If you intend to use light to evaluate the behavior of the space, you need to take into account some details of its harmonic behavior. The expansionary phase of the spring would fit into the first phase of harmonic movement carried out by light. As we said previously, if space were expanding in real time, galaxies would tend, sooner or later, to collapse onto the initial point due to the increase in elastic potential energy. Acceleration is predicted to exist in the opposite phase of the spring, that of its contraction. So, to understand the movement of galaxies from remote light tracking, these two phases of their harmonic movement need to be compared. Space expands in the first phase, in slow motion, and accelerates in the second phase, when kinetic energy increases and potential energy decreases. Thus, the problem of inflationary theories can be solved by making an unprecedented, and, why not say, bombastic statement. The galaxies would have continually moved away from each other in our past first phase of harmonic movement because space would be contracting in real time, second phase of the harmonic movement of light, justifying the acceleration. In short, the galaxies would move away from each other with ever-increasing speeds because space, previously curved, would now tend to become flat. When space contracted, light would be revealing its own expansion, but outside of its own time. The information would become accessible only in the second phase of the harmonic motion of light. This makes sense, because when you track light using the Doppler effect, you realize the enormous distances that separate us from galaxies and that need to be covered by light. For this, light needs time. Einstein's famous equation, E=mc2, tells us that there is no distinction between mass and energy. One can be converted into the other. As everything in the universe is basically formed by light or by the condensation of energy, our consciousness seems to have been trapped in space-time. That is, to know that galaxies exist, we depend on the light they emit into space. The same happens at the atomic level. To see an electron, it must first be illuminated. If the universe were static in its origins, it could not be grasped by our senses. Light would have set this universe in continuous and relative motion so that it could, finally, be reached by our memory. By transiently condensing, the light would have impressed our brains with the sensation of the passage of time. In a moment, the light is there. The next, it disappears. Between these ephemeral moments of light condensation, the real universe would remain static.